All right, now we have 8.3a graphing root functions. I guess I probably should have started the class with welcome back, but 8.3a graphing root functions. The parent function of y equals radical x. I'm just going to do some pretty basic drawings. Since it's a square root, when we go back to, I think, 2 lessons ago, the square root, it must be greater than 0, because this is going to be the Cartesian plane for real numbers. So it'll be of this form. And then cubic is where then you can have negative values. So that's more like this form. And we'll get into the actual plotting of points, but these are kind of standard for what these functions will look like, and you'll see what that is. We should be familiar to what our a, h, and k will do. H, k. A is a vertical stretch or shrink. H is associated with our x values shifting, and k is associated with y values shifting. So this is familiar to like unit 7, minus h. If we subtracted k to the other side, it'd be y minus k, which is what we were used to with like parabolas. So we do the opposite. Our ordered pair would be h and then k. And I'll explain that when we actually plot some points. So we're just going to start with, we have an index of 2, right? Because this is a square root. The implied index is 2. So our parent function is y equals square roots of 2. Or square roots of x. And we do have an a value. Our a value is 3. So when plotting the function, this is how we'll set it up. We want x and y, and then a times y. So let's go through and make sense of that. Since it's the square root, we need positive values for x. So 0, 1. I'm going to make them perfect squares, because you could put like 2 here, but then for y it'd be the square root of 2, and that gets messy. So instead I'm going to do perfect squares. So 4 and then 9. These will give us an idea of how this will look. So our output then is the square root of x, because y equals the square root of x. So that'd be 0. The square root of 1 is 1, 2, and 3. Now, our a value is 3, so we're going to take 3 times our y values. So times 3, times 3, times 3, and times 3. 0 times 3 is 0, and then we have 3, 6, and 9. So points that we are going to plot are going to be these, and now these. Now that we have those, our new vertical stretch here, we can disregard those points, because that's the parent function. The a value stretches or shrinks it. So now let's plot those new points. We have 0, 0 for our first ordered pair, 1, 3, 1, 1, 2, 3, 4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and then 9, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 will be up here. So now you can see how much of a stretch it is. The original function is a little more narrow, and it stretches it. So then we can look at our domain. Since it's real numbers, x cannot be less than 0. So x is greater than or equal to 0, and then it goes on for infinity, and y in this function is the same. Y, there are no negative values for y, so y is greater than or equal to 0. And that's kind of what we'll be doing today. We're graphing root functions. All right, so first, our a value is negative half. So just like graphing parabolas, we're going to have negative values for y. But it's cubic. So that means we can have negative values. So it's going to flip when it's usually like this. Now it's going to flip it so it's like this. I don't know if my cursor makes sense. So let's plot the points and make sense of it again. It's cubic, so for our points we're going to want to find, they can be negative. Perfect cubes then would include -8, -1, 0, 1, and 8. So we're looking for cubed roots of something. So the cubed root of -8 is -2. -2. The cubed root of -1 is -1. Again, cubed root, you can get negative values out. 0. So now that we're in positive values, 1 and 8, it's a +1 and a +2. Then we can see how our a will affect it. It's a -½ times y. So for all our values of y, we're multiplying it by -½. So -½ times -2, that gives us an output of 1. Then we have -1 times -½. So that's just half. We have 0 times -½ -½ and then we finally have -1. So now let's plot this. It's centered at the origin, and we can plot these points. We don't want our y values, we want our AY. Those are our new points. So we have -8, -8, 1, it's positive. So that's -8, 1, -1 half, 0, 0. We have 1 -½ and then 8 -1. So this is clearly a vertical now. Shrink, it looks like. It's real narrow. The domain still will be all real values for x. So we can label it as such. X is an element of all real numbers. And y, although it looks like it won't reach all our values for y, it will. It really would probably branch off higher here, and it would vertically reach all real numbers as well. Example 3, in this case we do have an h and a k. And let's think about what our leading coefficient, because that's our a. If we don't see it, there's an implied leading coefficient of 1. So let's label some of these points. A is 1, so it's not going to vertically stretch or shrink. H is going to be a +2. This is because we do the opposite. And K, it stays the same. This is going to be a +1. Because again, like I showed you at the beginning, if we subtracted that over, it would be like y -1. Then you would take the opposite. So we just have k is 1. So now we have an ordered pair for h and k. That point is 2, 1. And we're going to call this our new origin. And let's look at where that is at on the graph. 2, 1. We don't need that other point. So our origin, we have these like crosshairs for the y-axis and the x-axis. Let's do now the same for our new origin. This is where we're going to be shifting from or plotting our points. Now we can find our x and y. And let's look at the index. It's cubic, so we can have negative values. So -8, these are good cubed numbers. -1, 0, 1, and 8. So when we take the cubed root, we get -2, -1, 0, 1, and 2. So if we were centered at the origin, we would go to the left 8, down 2. Our new origin is here. So just like with our conic section, we're going to go from our, what would be like our center, and shift to the left 8 and down 2, because this is our new origin. So from here we go 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. We're shifting from that point. 1, 1. I went back 1, down 1. 0, 0 is a point. 1, 1, and then we have to go to the right 8 and up 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Now we see, whoops, what our new function looks like based off the parent function of y equals x cubed. The domain, because we can have negative outputs, x is an element of all real, and y is an element of all real numbers. All right. Hopefully, with each example, this makes more and more sense. Y equals -2, and it's the cubed root, and we have an h and a k. Again, let's do our a first. A is -2. H, we find the opposite. That's a +3, and k is a +2. I guess I could have just wrote 2 there, huh? Is 2. Our HK is the ordered pair, 3, 2, and again, this is our new origin. So 1, 2, 3, 2. We can make this clear that this is where we're shifting from. Now we want to find input, output, but now we do have an a that'll affect it. It's -2. -2 times y. It's cubic, so we want nice cubed numbers, just like we've been doing. Oops, not -2. -1, 0, 1, and 8. So that's -2, -1, 0, 1, 2. Now we have to multiply these y values by -2. So -2 times -2 will give us a +4, 2, 0, -2, -4. Again, we can disregard this middle section now and just shift from our HK these points. So our new origin is right here, and our first ordered pair is back 8 and a +4. So to the left 8, up 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Then we have -1, or +2. -1, 2. 0, 0 is a point. 1, -2. And 8, -4. 1, 2, 3, 4, 5, 6, 7, 8. We're just off the graph. And 1, 2, 3, 4. Right there. Now we can sketch our graph. And that's what that one looks like. Domain, again, cubic. So we can have negative and positive values. So x is an element of all real, and y is an element of all real. Couple more examples with each one. Hopefully you become more and more comfortable. So we have another, I'm going to actually, no, you know what? I am going to do it. We're going to do this one. More practice is better. So our a value is half. A equals half. H, we do the opposite, -3. K is -4. Our ordered pair is -3, -4. This is my HK. So that's our new origin, -3, 1, 2, 3, 4. From here, we will be shifting around the graph with our points. We have an X, Y, and an AY. A is half times Y. A is half. It's cubic, so we want those nice cube numbers again. Hopefully this feels almost repetitive. If it does, that means you're feeling comfortable. If not, that's okay too. That's why we're doing extra practice. So -2 over 2 is -1, -half, 0, half, and then we have 1. We don't want these. We do want our new output, which is a times that y. So let's shift those from our new origin, -3, -4. So -8, -1 from the origin. 1, 2, 3, 4, 5, 6, 7, 8, -1, -1, -half, 0, 0 is a point, 1 half, and then 8, 1. 1, 2, 3, 4, 5, 6, 7, 8, 1. So there's that, and there's that. The domain, it's cubic. So again, we have all real for both our x and our y. All right, extra example here. Now our index is 2, so square root. So we can only have positive values here. A, these steps are going to be the same. A equals 2, h equals -4, because we do the opposite, and then outside, k is -1. So our hk is -4, -1. 1, 2, 3, 4, -1. This is where we will be shifting from. It's a positive coefficient. The parent function off to the side was of that form. So it's shifted back here, and it's a is greater than 1. So it's going to stretch a little. So then we have x, y, square roots. We need positive values, and we want nice squared numbers. So outputs 0, 1, 2, 3, and then our ay is 2 times y. So 2 times 0 is 0, 2, 4, and 6. Now we can plot those. So our origin is -4, 1. So from the origin, we go 0, 0. So that's that point. We go +1, +2, +4, +4, 1, 2, 3, 4, 1, 2, 3, 4, and then finally 9, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6. This gives us a good idea of how the function will look. The domain, now there are restrictions because we cannot have negative values for x over here. So x is greater than, well, our h value is going to be an indicator. X will be greater than or equal to our h value when it's the square root. And then we could do the same thing with our k value. Y is going to be greater than or equal to, because we're looking at what the graph looks like, our k value, -1. That's then what the domain and range would be for that. All right, and we have one more extra example. So let's go through it. A is going to be -2. So it's a square root and a negative. So I think that should already be indicating which way it's going to open. But with finding our points, we'll find out anyways. H is going to be -3, and K is a +5. HK is -3, 5, so that's our new origin. 1, 2, 3, 1, 2, 3, 4, 5. I didn't mean to mark that point. So like so. Through this point, we can find x, y, and then ay. Square root, so positive, nice squared numbers, 0, 1, 4, 9. The square root of those then, and then a is -2 times y. So we have 0, -2, -4, -6. So it's going to be opposite, because this was a positive 2 for A up here. So positive, these are now negative. So it's going to open down like this. Mirrors over the x-axis. So from our new origin, 0, 0, so that's the point right there. We don't shift at all. 1, negative 2. 4, negative 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 9, negative 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So it flips over that x axis that we shifted. Now the domain is going to still be positive values for x from this point, which was our indicator is our h value. So x is strictly greater than or equal to h. But now our y values are down. They're going to be decreasing from our k value. So y is going to be less than or equal to our k value of 5. So with homework, practice these, ask questions if you have any, email me. Hopefully with the abundance of examples we had, you felt more comfortable by the end of the video with what we were doing. So thanks for watching. Let me know if you have any questions. See you later.